welcome to Clean Coder YouTube channel. If you are new to this channel, I'll highly recommend you to subscribe to my channel as I make content related to software engineering, system design, and data structures and algorithms.
Hello everyone, welcome to Clean Coder YouTube channel. So today we are going to solve this lead code problem number 103, binary tree zigzag level order traversal. So let's go through the problem statement quickly. By the way, this is a really commonly asked interview question. If you interview for companies like Amazon, so you can expect this kind of question in their face-to-face interviews. Even I have faced these questions many times in interviews. So please pay attention while solving this problem. So let's start. So the problem statement states, given the root of a binary tree, return the zigzag level order traversal of its node values. That is from left to right, then right to left for the next level, and so on and so forth. So in this example, 3, 9, 20, 15, 7. So what he has done is 3. First he has iterated 3, and then he has taken a right turn first, and then he has reached the level 20 via right side. So from right to left he has iterated. So 329, and then he has again moved to the next level and moved from left to right. So 15 and 7. So the output is 3, 29, 50 and 7. So the next input outputs are a kind of corner condition. So these you can go through your own, and let's try to go through some of the constraints. So the number of nodes in the tree is in the range 0 to 2000. Okay, so this is fine. And after that, the values would be between -100 to +100. This is also fine. So let's try to visualize this problem on a whiteboard. So wait a second. Okay, so let's start. So let's say we have a tree like this. 1, 2, 3, 4, 5, 6, 7. Let's say one more level. 8, 9, 10, 11. Okay. So we have a tree like this. So what will you think be the zigzag order traversal of this tree? So it will be like this. Okay. So this is a zigzag level order traversal of the tree. So let me write the output also. So it will be 1. So the output will be 1, 3, 2, 4, 5, 6, 7. After that, it's continuing to 11, 10, 9, 8. The output is going to be like this. So let's try to think of some approaches how we can solve this problem easily. So the approach which I was able to thought of was, let me tell you my approach. Actually, there are many ways to solve this problem. You can solve this problem using different combinations of stack and queue. Okay, we all know that a simple level order traversal we can solve it via queue. Okay, but here what they have asked is they want zigzag, right? Zigzag. So how you would introduce a zigzag in this queue? You just need to think of this. Okay, so the answer is pretty straightforward actually. We can use a stack with queue, right? Stack with queue, and this stack introduces the like direction change, right? Direction change. This is one way to solve this problem, right? This is fine, but I was able to think of the solution with stack and stack. Okay, I am going to use two stacks to solve this problem. Fine. So what I'm going to do is, let me give a brief overview of my approach. So let's say the tree is like this: 1, 2, 3, 4, 5, 6, 7. Let's say there is 1, 8 and 9 here. Okay, so the answer will be like this, right? Fine. So what I'm going to do is, these are my two stacks. Okay, so these are my two stacks. So I'm going to, let me call this stack as stack number 1. Okay, stack number 1, and this is my stack number 2. Okay, so let me insert the node number 1 to the stack number 1. Okay, and what we are going to do is now take the element out of the stack. Like, let's start from the stack number 1. So what we want to do is, we want to iterate that, we want to print that output here, and at the same time we want to insert its child to the right stack. Okay, to the stack number 2. So whenever we are inserting the childs from stack 1 to stack 2, this direction, what I'm going to do is, I'm going to follow the order: left child first and then right child. Okay, and similarly I'll explain you that whenever we are going from stack number 2 to stack number 1, we're going to follow the order as first right child and then left child. Okay, so let's quickly try to quickly try to dry run this on this tree. So 1, I have already iterated, I can remove that from the stack. Okay, so I'll remove and I'll put its children here, first 2 and then 3. Now the stack 1 is empty, I can move to stack 2. So I'll pop 3 from it, and what I'll do is, I'll put the children of 3 in stack number 1, but in order right and then left. Okay, so in order right and then left. Okay, then 7 and then 6. Okay, the 3 is iterated already. Now the next turn is of 2, so I will iterate for 2. Let's do that quickly. So 2, and now the children of 2 in the order right first and then left. Okay, so sorry, so in the order right first and then left, so it will be 5 and then it will be 4. So my stack 2 is now empty, I need to move to stack 1. So I'll print 4 first. 4 has no children, so it will be simply popped out of the tree. Okay, and then for 5 I am going to follow the similar procedure. First we need to put 8 and then 9. Okay, and I'll pop 5 out of the tree as well. 5. Okay, the next turn is of 6. Okay, 6. The next turn is of 7. Okay, because they don't have any children, so I'm directly like just iterating over them. And now similarly the right stack will become empty, or the stack number 2 will be iterated and we'll make it empty, and since they have no children, we'll be emptying them as well. Okay, so the output will be 9 and 8 here. So hence this traversal I am able to do with 2 stacks. Okay, so let's try to code this approach quickly, and after that we are going to do the time complexity analysis. So yeah, I need to take 2 stacks. First let's okay, I need to do that level by level as well, no problem. I can make a list of integer, list of integer. Okay, so integer answer equals new array list. Okay, we can make a list like this. After that, if my tree is empty or null, I can directly return this list. Okay, return answer, this kind of base condition. So let's move forward now. Let's take two stacks, stack of integer, or stack of let's directly take three nodes. This is stack 1 is equals to new stack of three nodes. Stack 2 is equals to new stack. Okay, so let's try to write the code for these two. While stack 1 dot is empty is double equal to false, stack 2 dot is empty double equal to false. Okay, so while both the stacks have any element in them, I'm going to iterate this loop. Okay, so I need to insert the first tree node in stack 1. So s1 dot push root. Okay, so now let's write our logic. If s1 dot is empty double equal to false, what I need to do is I need to make a temporary array list of integer temp is equals to new array list. Okay, so I'm going to add temp dot add stack 1 dot peak. Okay, then I'm going to collect that in a temporary variable, tree node stack 1 dot tree node t is equals to stack 1 dot peak, and then I'm going to insert its children in stack 2. So stack 2 dot add t dot left, and stack 2 dot add t dot right. You remember the order when we were inserting from stack 1 to stack 2? So when we were inserting from stack 1 to stack 2, the order was LR. Okay, so you need to pay close attention to this. Okay, so the order is left to right. Fine. So I need to obviously do the null checks also here. If t dot left is not equal to null, okay, only then I am allowed to perform this operation. Fine. Similarly, if t dot right is not equal to null, only then I am allowed to perform this operation. Okay, so here we go. Similarly, a block will be there for S2 as well, right? S2. We can have a Boolean variable as turn. Turn is equals to false. Okay, so initially the turn would be of stack 1, so I'll write if turn is double equal to false. Okay. Similarly, in the else condition, the turn will be of S2. Okay. Let me quickly paste this code. S2 empty is double equal to false. S2 dot P S1 S1, and order will be reversed, right? It's going to be like this. Okay, so there are some more things we need to do, right? First of all, we need to think about how we need to change the turn variable, right? So how we can uh, change the turn variable. Okay, so it's simple, quite simple actually. So turn is equals to true. In this else part, just write and just do this thing. Answer dot add temp. Okay, and temp is equals to new array list now, or write like this. Okay, wait a second, let me think about it. Else turn is equals to false and answer dot add temp. Okay. Yeah, we can write it. Temp is equals to new array list here. I think this is fine. Temp is equals to new array list. Yeah, this is fine. Let's copy this part in both the sides. I think that's all. Let's first dry run our code and check if we are doing everything correctly or not. So let's start from the top. Okay, we have root, we have the answer element, answer list of list, which we are going to return. If root is null, this is the base condition. I have two stacks, this is fine. I have put in the stack 1 the root, this fine, and turn is for the stack 1 first. So then I have taken a temporary array list for each level. Okay, then I am iterating in an infinite kind of while loop. Not infinite, we have the terminating condition as if both stacks becomes empty, then please take me out of this while loop. Okay, so if stack 1 empty, if stack 1 becomes empty, this is going to be true. This comparison is going to result in 0, and 0 like false or false, it will be false, so we'll be out of this while loop. So turn false means it's the turn of the first stack. Okay, so just writing empty check here for the stack 1, and I'm adding that in the array list, and I'm capturing that in a temporary variable t, and I'm checking its left and right children and inserting them to the stack 2. Okay, and in the else part, when the stack becomes empty, I'm just flipping the turn, adding my answer and initializing temp with the new empty array list for the next level. Okay, similarly for S2, I'm doing the same things, like this block is actually a reverse of this block for S2, right? Just the only thing is you need to be careful. For S2, you need to insert the right child first and then left child. Okay, in S1, so the order is RL here. Let me write that itself. The order is RL, right child first and then left child, and here the order is like left child first and then right child. This is the only difference we have. So in the else part, I'm doing the turn false. Adding the answer. I'm adding the temp to the answer, and I'm initializing the temp with the new empty array list. So I think this is fine. Let's return the answer, and let's check if we are doing everything correctly or not. Let me run this code once. Wait a second. Okay. So we don't have a peak. Oh, sorry. So incompatible types tree node. Okay. So we need to do here. What is the structure of tree node? Okay, tree node dot val, right? Tree node dot val. I need to perform. Okay. Here also, I think I need to make new tree nodes, right? New tree node. It will be like this. Just a small change. We need to do it everywhere. We missed this earlier. Okay. I think this is fine now. Let's run this once. No. Okay. Sorry. It was fine. T dot left is fine. It's reference to tree node itself. So this is fine. Okay. Yeah. Let me run this again. So dot p dot val. Okay. Oh, time limit exceeded. What we are doing wrong? Wait a second. I got that. What we are not popping any element from stack. This thing you need to be careful. If you get time limit exceeded, it means the stacks are not getting exhausted, right? So you need to pop the elements from stack as well. So I'm going to do something like this here. S1 dot pop. Similarly here, S2 dot pop. Okay. So let's submit this again. No, sir, we are not getting the correct output again. So 329 is fine, but 1517 for some reason we are not getting. So we need to debug this. What's the reason? Okay, this was true, this was false. Okay. That too. What mistake are we making? Wait a second. looks good here. Less temp. Okay, sound dot m is empty. Till the time both the stacks are not empty. Cool. Turn false, it means first stack turn. Empty is false. Okay, temp dot add. I'm adding. Okay, s1 dot peak. This is fine. s2 dot add. T dot left. T dot right. This is fine. Looks fine. At least. Else part is turn is true. Okay. Other dot add temp is given. This is fine. After that, in the else part, turn is true. S2 dot is empty is false. S2 dot peak dot value t. Okay, S2 dot peak. This is fine. So dot add t dot right. So dot add t dot left. S2 dot pop. This is fine. Turn is equal to false. So add temp is equals to new carry list. What are we doing wrong here? Somehow my last level is not getting printed for some reason. 3, 29, 15 and 7. So first time I got that 20 and 9, and after that is empty is false. So what is empty is false. Both the stacks became empty. How is this possible? Wait a second. 3. Okay, 29. I put that there. 3, 9, 20. That's fine. This became empty. Return was this 2. This empty as is not empty. Temp dot add as dot peak dot value is fine. Tree as dot peak. T dot right. I put 7 and then 15. Okay. 7. Okay. Not equal to null. 100 at t dot right, t dot left is not equal. That's 1 dot at t dot left. Okay, so dot pop is fine. I popped 20. After that, I popped 9. So 9. Okay. T dot d as to peak. 9 has no left or right. So nothing here. So dot pop 9 is gone now. Okay. So next time it came. Turn is true and S2 is empty actually. So I made it turn as false and I added my answer to temp, which is coming also by the way 29. Initialize temp with new array list. Okay, this I've done. So I'm missing the last level by the way, right? Okay, I got that. You know what? You just need to do wait a second. Answer dot add temp. Now let me run that again. Yeah. Let me submit this once. Yeah, here we go. Oh. So finally accepted solution, and I think we are doing pretty well. So if you have any doubts related to this problem, feel free to enter that in the comment section. I'll be more than happy to resolve any of the queries related to my approach. If you liked my way of teaching and if you like this tutorial, do give a thumbs up and do subscribe to my channel for more videos related to problem solving, data structures, and algorithm. So once again, thanks for watching Clean Coder. Bye bye.
Hey guys, do check out this Instagram channel, Clean Coder Community, for all the jokes and memes related to software engineering. Thanks a lot.